Welcome back. This is lesson 12.4 Journal. We are going to be learning about histograms today. I will be able to create and read. This should say histograms. Just one word. Histograms for any data set. I will also be able to create related frequency tables to make sense of a data set. So vocabulary for this lesson. Data, we've talked about, that is a set of information pieces that you gather. Frequency is how often a data piece occurs in a data set. Frequency table is how we can organize pieces of data based on how often they appear. Relative frequency is the percentage that they appear out of the total. Histogram is new, so you're going to need your vocabulary sheet for this one. And interval is also new. So interval is going to be down here at the very bottom of the page. We filled out up to here. This is a new page because my other one got lost. So you should already have all of this filled up to here. Interval is equal sized sections of a number line or a data set. So what we're going to be doing is we will be splitting the number line up into equal portions to get our intervals. Okay, backside. A frequency histogram is a graph that uses vertical columns to show the frequency of an interval within a data set. Okay, there are no gaps between the bars. All right, you can put that away for now. Let's go ahead and learn about histograms. So it says, Jared asked each student in his class how many students were in their family. The following is the data he collected. So one kid has 3 kids in his family, 2, you get the idea. So it says create a frequency table with 4 intervals, then make a histogram of the data set. So to find intervals, we need to find the size each interval will be by subtracting the largest number from the smallest number to find the range. So the largest number I see here, 6, maybe 8. Okay, 8 kids is the highest anybody had. Subtract the lowest amount of kids, 1. Why are there no zeros? Because if he's asking each student in his class, there's got to be at least 1 kid in their house, right? So 8 subtract 1 gives us 7. Now we're going to divide that number, so that's the span of the number line we are covering. We're covering 7 numbers. So divide that number by the number of intervals needed. So I'm going to take 7, and I'm going to divide it by 4 because we want 4 intervals. That would give us 1.75. 7 divided by 4 is 1.75. So we're going to round up so that we have a whole number because we can't have 1.75 kids. So we're going to split it, round it up to 2. And you always round up, even if this is 1.01, you'd still round up or you wouldn't have somewhere to put that last data piece. So this would round up to 2. So in other words, we're going to make each interval 2 units wide. So each interval is going to be 2 units wide. So we're going to start with the lowest number. We had 1 kid. That was the lowest number of kids we had. And then 2 more than that. 1 plus 2 would give us 3. So you see how I jumped from 1 to 3 here? Well, that means this is going to go from 1 to 2 kids. So you see how there's 2 numbers in there, 1 and 2. So this would be 3 to 4, That makes this next one 2 more than 3, which would be 5. Make this one 5 to 6. That would make this one 7 to 8. Now you see how those are split evenly, and we got from my lowest kid all the way up to our highest amount. Now the tally is just a way to organize how your frequency for these numbers up here. So to make it easy, all I want you to do is look, this is 3. So I'm going to cross it off and I'm going to put a tally here because 3 fits between 3 and 4. 2 fits between 1 and 2. 2 fits between 1 and 2, and keep going. Four is between 3 and 4. 3 is between 3 and 4. Just don't make sure you accidentally miss something. Last one is 1K. Oh, that would have been better to do that. Okay, so one thing that helps me is sometimes I miss a number up here, so I'm going to count how many I have here and count my tallies, make sure I've got the same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 kids in his class. 10 plus 8 is 18, 19, 20, 21. Means I probably didn't miss anybody. So the frequency, or how many kids were between, how many families had between 1 to 2 kids? There were 10 of them. How many had between 3 and 4? 8. 5 and 6, there were 2 families, and 1 that had between 7 and 8. Now a histogram, you've got to make sure that you label things, okay? This down here, the x-axis, is always going to be represented by what you are representing. So in this case, it was the number of kids in their family. This one's going to be the frequency. That's why it's called a frequency histogram. You're graphing the frequency. Now why would this be useful instead of a dot plot like we did before? There are going to be some times when you don't need to know exactly what the pieces of data are. It's helpful to see just things in groups. So what you've done here is you've grouped all the ones between 1 and 2, 3 and 4, 5 and 6, 7 and 8. So our frequency is going to be numbered here. This is going to be a little bit different. You're going to want to put numbers on these. These are the dividers though. So from here to here, this would be 1 to 2. We're going to put a little squiggle here because we're skipping 0. So 1 to 2, this section right here would represent 3 to 4. You're showing your intervals. This section, this section, this section would represent 5 to 6. And this section would represent 7 to 8. Alright, so we also need to put the frequency here. We also need to have a title. So what's a good title of this? Number of kids in family. Now, after I make this graph, it will be easy to interpret what we were trying to show. So we need to get up to 10. I have 1, 2, 3, 4, 5 lines. So I'm just going to number by 2s. 4, 6, 8, 10. Now here's where it's just a little different. You're going to want to make a bar graph. A histogram is a special bar graph. There will be no gaps between the columns. So right here at my divider, I'm going to go up to where I want to be. So 1 to 2, I had to go all the way up to 10. So you see how I'm not leaving any gap? And then I'm going to shade it in. So I'm showing that families that had between 1 and 2 kids, there were 10 of them. 3 to 4 kids, there were 8 of them. So I'm going to go from here straight up to 8. Remember, no gaps. 8's about right there. And we can even write above it if we want to, just to make it clear. Sometimes they don't. You have to read the graph. But you can see, I come up to here and I can see that that's at 8. 5 to 6 is 2, so I'm going to go up to where 2 is. We can write a number over it if we want. And then 7 to 8, we had 1, so that'd be halfway between 2 and 0. Okay, we've made a histogram. Now, I could answer some questions like, most families had between what? Well, we can see that of these, most families had between 1 to 4 kids. 18 of the 21 families had between 1 and 4 kids. Now, looking at this, can I tell you how many had exactly 1 kid? No, I'd have to go back to the data. So this kind of graph is not to pick out how many had exactly a certain amount. This is more just for grouping an idea. Alright, so that's how to make a histogram. Let's try reading a histogram. So here we have weights of dogs, that's our title. So our weight is in kilograms, so this one must mean that this is dogs between 0 to 9 kilograms, 10 to 19 kilograms, 20 to 29, and so on. Number of dogs, or the frequency, this would have been the number of families. We could also write that up here. So the number of dogs, or the frequency, they could have written frequency here as well. So let's answer these questions. What was the total number of dogs? Well, there were 5 in this category, plus 15, plus 24, plus 35, plus 16, plus 6, plus 4. So 5 plus 15, that one's easy, that's 20, plus 24, plus 35, plus 16, I'm going to make this easy, 4 plus 6 is 10. So 4 plus 5 is 9, 9 plus 6 is 15, regroup 1. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 9, 10. So there were 105 dogs total. How many dogs weighed less than 30 pounds? Okay, less than 30 pounds, this is 30 to 39, so these weren't less than 39. That means anybody in this category, or this category. So 15 plus 5 is 20, plus 24 more. 20 plus 24 is 44. So 44 dogs weighed less than 30 pounds. Now, can I tell you how many weighed exactly 24 pounds? I can't. That's where this group data is not useful. So if you're looking for a specific exact weight, not useful. But if you're trying to get a good idea of where most dogs fit, this gives us a really good idea. So what is the relative frequency of dogs that weigh between 20 and 49 pounds? So we're going between 20 to 49 pounds. Any in this column, or this column. But we want the relative frequency, not the frequency. So remember, relative frequency is out of the total. Well, let's figure out how many dogs weighed between there. So 24 plus 35 plus 16. 10 plus 5 is 15, regroup 1. 1 plus 2 is 3, 3 plus 3 is 6. 6 plus 1 is 7. So this would be 75 out of a total of 105. So if I'm going to turn that into a decimal, well, it's okay to pull out your calculator for this one. My battery's dead apparently. Let me go grab another one real quick. $75 divided by 105 equals 0.71 blah 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 to the nearest percent So the hundredths place would be 0.4. So I'm just going to say 71.4% would be the relative frequency. That's a good enough rounded one. Now, can this tell you how many dogs weighed 21 pounds? Why or why not? All we have are intervals, which are groups, and so we can't get exact ones. So, no, because histograms show group data, not individual data. Not individual numbers. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.